Hey Algebra 1. Well, welcome back to another week of distance learning. This will be some information for you for week 2. This video is going to basically go over notes that you'll want to utilize for the next lesson on properties of parabolas. You'll want to go through these notes and kind of walk through each part of it before you do the assignment on properties of parabolas. I'm going to get off camera and have a seat under the document camera. You'll see me working up here, so I may not be on camera much, which won't be a problem because I'm not looking too hot these days. I've converted my upstairs playroom into a classroom where I can video, and I brought all my equipment from school here so I can work. I want to just tell you again, I love you, I miss you. I want you to stay home and stay safe, and let's have a seat now. Okay, so if you need to go ahead and hit pause to get your materials together, you can. I actually just went and got, my math notes out, so you'll want to get your notes. Last week we talked about graphing quadratics, and you can just put that together with this one if you want to in your notes. If you didn't write anything last week, not a problem. And so it's just really topics 35 and 36. They kind of go together because you can't kind of label the properties of the different attributes of a parabola without having first graphed it. And so really this kind of all goes together. So feel free to do that. What I did was just kind of put both titles at the top. I even put on the very bottom, I put pages 35 and 36, so you can definitely do that. Now, one other thing that I have that I'm using today is a sheet of graph paper. And you're gonna, I think, want to have one of those. So definitely, if you don't have any graph paper available to you, maybe you need to hit pause and run to the store and get some, or download some off of the internet. You can just Google that really easily and print you off a sheet. And all I did was just take a pair of scissors and cut it to size. And I'm just going to lay it right here. You can glue it in some other time if you'd like. All right, so one of the first things I want us to do is I'll actually give you an equation to graph. And we could say y equals, or remember, we can also put it in this. It's called function notation. F of x equals, we know that's the same thing as y equals. F of x equals x squared plus 4x minus 5. X squared plus 4x minus 5. And we're going to want to graph this. And so one of the easiest things to do, of course, is go to your graphing calculator, input that calculator into y equals in your calculator, input that equation, x squared plus 4x minus 5. Now remember, type of 5, a minus 5, not a negative 5 there, or it'll try to multiply. What you might want to do is just go take a look at it first on the graph to kind of see where it is. You kind of get a good idea of how it's placed on the coordinate plane. Where it takes its turn is over here in quadrant 3. Crosses the y-axis below the origin. And it crosses the x-axis in a couple of spots here and there. And then takes on off, forever upward. So that kind of gives you a good visual of it. But to be able to graph it on a coordinate plane, you really need some ordered pairs. And so, of course, to get that, we need to go into the table. So I'm going to hit second graph to go into table and snatch up some ordered pairs. I'll be honest, when I first started, my screen was like off somewhere looking like this. But I began to look for some zeros somewhere. I'm just looking for zeros. And one of the things I noticed is 0 here and one's over here. But I want you to notice something else. I began to watch for. Do you see how right here in the middle I have -9, and then either side of that I have a -8, and on either side of that I've got a -5, and then it keeps branching out, but mirror imaging those numbers both above and below, and it'll keep doing that. Like if I went on up, that's a 7. If I went down this way, there's a 7, and it's going to kind of keep mirror imaging all the way through there. And that's a good thing to see. That helps you, those ordered pairs kind of create the skeleton points for you to kind of flesh out and build your parabola. So let's go over here to the side of our paper and let's create a t-chart and list some of these ordered pairs. I want to take a quick check and make sure that everything's showing up on screen. Great, looks like it is. All right, and so I want to just, I don't want to pick crazy points that aren't going to fit into my graph paper here, but I think that I would start. Yeah, let's don't go all the way out to 16. Let's start right here at -6, 7. And I'm just going to jot these down. I've got -5, 0, -4, -5, -3, -8, -2, -9. And then I'm going to continue on and extend that chart down so that I can kind of get the mirror side of all that. So I'm going to scroll down here in my calculator. We've got -1, -8, 0, -5, and I can pretty much already guess I got 1, 0, and 2, 7. All right, so what I want to do is graph each one of those ordered pairs, and I want to remind myself of what the graph looked like, and so I can set my axes to kind of do that. I know I need to get all the way down. My lowest y value is -9, my highest is 7. So I think I need more space on this side of my y-axis, so instead of putting my y-axis right in the middle of this space, I'm going to kind of drift over to the right just a little bit and give myself some leftward space. Because if I look at my x's, I'm going to go all the way to -6 when I'm only going to +2. So I may come over even a little more. Matter of fact, I'm going to double check myself and make sure. -1, 2, 3, 4, 5, 6. Yeah, 1, 2. So this will be a good spot for my parabola, or for my axes. So I'll just build my y-axis right there and label it as a y. And let's see. I got to go on my up and down my y-axis. And my x-axis, I need to get all the way over to -6 and then +2. We said that. I got to get up to 7. Y, -9. So I got to go further down the y-axis than I have to go up. So if that's 7, 6, 5, 4, 3, 2, 1, 0, that'll work. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, this will work right in here for my x-axis. It does take a little while to set this up, so don't panic. And in your assignment on the graph, I'm going to have all those there for you anyway. You might want to go ahead and label a few points out, 1, 2. If you want to, you can go out by 2s and not have to label every single line. That's kind of burdensome. So if you wanted to count by 2s, you can. You're still going by 1s, -1, -2, -3, -4. You just don't have the label. So there's 1, 2, 3, 4, 5, 6, 7, 8. -2, -4, -6, -8, -10. All right, so you got it all fleshed out, and now all you need to do is plot these ordered pairs. So I'm going to grab a different ink color here and let's get after it. So -6 and +7 would be right here. -5, 0. -4, -5, right there. This didn't look right to me. -3, -8. -2, -9. And then it starts to turn and come back up. -1, -8. And now you're going to see those mirror images as you come up. 0 and then 2, 7 will be up here. And so you can kind of just see how if you were to kind of connect the dots in a flowy line, and I'm going to do this in pencil because, you know, sometimes you kind of have to erase. These are so far apart. And as you're building these, you just kind of make them as smooth as you can. And remember, don't come to a sharp point here because a parabola actually turns and is more of a U shape and not a V shape. A V shape is what you get when you do an equation called an absolute value equation, not a quadratic. So try to make it a little bit of a smooth corner. And it doesn't have to be absolutely perfect. I want you to do the best job that you can, but just kind of give it a rounded bottom right there. So there it is. There's our parabola. If you did it lightly the first time, you might want to come in, make it a little dark the second time. All right, so now it's time to actually, you know, make some labels. We're talking about the properties of it. Right now we haven't done anything more than what we did last week. That was just graphing it. And so now I want to go a little bit further. And so some of the things that we're going to label are some of the basic obvious things that you already are aware of. Number one, that's where it crosses the y-axis. So that's at -5. Now I'm going to bring in that label because I want to visually see that number. That is the y-intercept. That's one of the things that we want to pay attention to. I noticed that it also crosses the x-axis at 2 spots. And we've been talking about that. It crossed at -5. It also crossed here at 1. So this right here is an x-intercept. And this as well. And I think what I'll do is kind of draw an arrow over there. Those are both x-intercepts. Now that also has some other names. We called them before the x-intercepts. You heard me refer to them before spring break and all this happened. I called them the zeros, and I pointed out why. If you look at this point where it crosses the x-axis, it's here. It's when y is 0. The other one is here. So they are referred to as the zeros. That's a 0 and that's a 0. I guess I shouldn't have had that S on there. You have a couple of zeros, and here they are. They turn out to be the x-intercepts. Some other names you can also, they're called the roots. If this were kind of like a plant growing, it's like blam. This is the plant's up above the ground, and boom, when it hits the x-axis, it's like the roots begin. It begins to grow under the ground. So that's one I always kind of have in my mind as I refer to those as roots. Sometimes you can just call them the answer or the solution. Because if you were to actually graph or factor this out, you would have x and x. You'd have a +5 and a -1. And that would be the factorization of this quadratic. And if you solve for x, x would be -5. Or this one, I've kind of crunched it up, but x would have to be +1. And look at there. Those are your two roots, +1 and -5. They match. So we've been doing that all along. We didn't quite know what to call it, but that's the label here, and you have a y-intercept. Okay, so there's a couple of things that we need to label that you've never seen before. You can imagine, we talked about the mirror image, that a line right down the middle where it was the same numbers on either side. Kind of here was the middle of it, and then you started having mirror imaging happening out like that. And so that line was centered around this right here. Right here, this lowest point where it made the turn. Now on this line, I want you to make it a dashed line. Don't make it a solid line. Make it dashed. It's kind of the universal way of showing that. And put arrows on each end because it does keep going. That line right there is referred to as the axis of symmetry. It's the axis of symmetry. Because everything is symmetrically placed around it. Axis of, let me get it where you can see it. S-Y-M-M-E-T-R-Y, the axis of symmetry. And then we're going to talk about how to calculate the axis of symmetry as well. Matter of fact, now is the best time of doing that. X is going to be equal to, remember it's a vertical line, so it's an undefined slope. They start with x equals, and what it will be the opposite of the b value over 2a. If you'll recall the quadratic formula, that's a little piece of the quadratic formula. Well, I go back up here to the top. Remember the b value, the a is an understood 1, b is a +4, and c is -5. But I want the opposite of the b value, so that would be a -4 over 2 times the a value, and the a value was an understood 1. So the a value is an understood 1 right there. So I'll have -4 over 2, and that simplifies to -2. So x equals -2. That's your equation for your axis of symmetry right there. X equals, -2. So when you label your axis of symmetry, you also have to write its equation that goes along with it. Graph it and write the equation, and that's how you solve it right there. Okay, we're almost done. The last thing you have to do is name this point right here where it makes its turn. That is referred to as the vertex. And you can name the vertex. It's a point, so you name it, not with an equation, but with an ordered pair. The name of that ordered pair is simply -2, 9, and we can see it right here in our table. But you could just look at it and go where you, from the origin, and walk out to -2 and down 9. So -2, -9, and that is your vertex. your axis of symmetry. All right, so the properties, let me kind of screen this out a little bit again. Properties for your quadratics that create this parabolic shape or a parabola have, we've got y-intercepts, you've got x-intercepts, also known as roots, zeros, or the solution. You have an axis of symmetry that names this line that cuts it right down the middle. You'll actually label it with an equation, and then you'll actually label this turning point. Now, something else about this turning point, this is as low as it ever gets. So this vertex is specifically the minimum. It's the minimum because that's the lowest any point on that parabola will ever go. If you happened to have a parabola that opened like this, then you'd have a point right there where it makes its turn, and that vertex is as high as it ever goes. So that's the maximum. You might want to just jot that down in some spot. Your vertex could either be a minimum or a maximum. All right, I don't want this video to be too long, and so I'm going to go ahead and stop that right there. Be sure to get all of that in your notes, and I'll record a second video to actually go over some of the homework. Thanks, guys.